So I'm going to show now how to use ParaView to post-process and visualize output from the digital mixing tank. ParaView is a very general-purpose scientific visualization software package. It's open source and free. It's developed at national labs here in the United States. So it's well supported and very powerful. So let me go ahead and open up some data that I generated from a previous run of the digital mixing tank. Just to, again, summarize, some of these files should look familiar, but just again to revisit, fluid all, that's the entire flow domain. So I have two snapshots of which I printed all the entire domain of the fluid, and I can then look at domain-wise properties. I have fluid XYZ. I printed these much more frequently, and these are just fluid slices at the, about the XYZ planes centered at the impeller mount point. I have full impeller and impeller. So the impeller is printed at the same frequency as these planes, so 0, 13, 26, 0, 13, 26. If we're loading up planes, we look at this impeller file, such that as we evolve through in time, the impeller STL is rotated at the correct position to match what was going on in the simulation. If we look at the entire flow domain, which is maybe printed off at different time frequencies, we open up full impeller. That way those image outputs will match that of the full fluid domain, such that the impeller will be in the correct place as it was during the simulation. So I'm just going to look at planes right now. So I'm going to open up the three planes. I'm going to open up the tank, and I'll open up the impeller files. And the little chevron here implies that there are many of these. There's a time series of these. There's no chevron for the tank. There's just one tank. It doesn't change in time, obviously. So let me go ahead and open these up and hit apply to kick them into the system. And so it's loading these things up. Make it 3D by clicking on that 2D, 3D button. And there it is. I mean, here are the planes within our system. So I can choose any particular feature within the pipeline browser. Note here that the fluid has several parameters that I can tune to. I can look at velocity, mean velocity, total kinetic energy, average turbulent kinetic energy, EDR, vorticity, etc. I can choose to look at any of those things. I have the tank, which is just an STL, and the impeller, which is an STL, but again, it has an asterisk here because there are many impellers, each of the unique time series. So if I go up to the fluid and let's say I choose to visualize, right now I'm coloring it by velocity. I can choose to color by any of the components, but they're all going to be equally boring because I'm at time step 0 and nothing's happened. Like this is the first simulation time step. So if I show the axis here, like it's going from 0 to numerical 0 for all intents and purposes in our simulation. Nothing's happening. If I jump ahead to some future time step, let's go to the end of the simulation. Like suddenly thinks it's velocity everywhere because again, because there are finite values now, they exceed the range of the fluid's initial color scale. So I just rescale. I click right over here and rescale back to where it should be. Right. So now you can see this velocity scale goes from 0 to about 4.91 meters per second, and that provides a more appropriate scale for the duration of the simulation. So if I go back, everything still looks blue because relative to this scale as well, it has 0 velocity. But if I go somewhere in the middle, say let's say 50, let's go to 50 here. Again, the scale is more appropriate. I always normalize by the last frame. It's just kind of my habit. I can change the appearance of this color scale. I prefer blue to red, but you can choose whatever you want to choose. You can change the range here. Maybe I'll just go up to, let's say, a 4. And it makes more of it red, but it provides more detail in the low velocity regions. So the tank sometimes gets in the way, so you can eliminate it either by clicking on the eye, make it appear or disappear, or if you like to show its effect, but rather want to tune it down a bit, you can put in some, transparency setting here. So I can change how visual or how much I want to see that tank just by changing this transparency. So I'm just going to turn it back to 1, and I'm just going to turn it off, actually. I don't want to see it right now. I'm also going to turn off some of these extra planes. I'm going to turn off, I'll turn off the X plane, and I'll turn off the Z plane. Okay, so now I just have my impeller spinning about this Y plane. And again, so it's showing velocity. I can choose, if I go back up to Y plane, I can choose to look at any component. I can choose to note the axis here was changing. So the Z velocity is somewhere between positive 5 and minus 5 meters per second, which should make sense. The Y velocity we expect to be much lower, Yeah, we're getting ranges of say 1 or so meter per second, just because there's not as much motion happening in that direction. Go back to magnitude. We can look at things like eddy dissipation rate. So again, there's lots of physics we can resolve from the simulation here. We can again change the color scale to whatever we choose, and change the scales if we think that's too much range. We can decrease it and see more of what's happening in the far field. So again, there's lots you can do here, and one key point is that if I want to change these scales, I've got to be on the pipeline browser menu item that I want to change. So I can't be on tank and change the color scale of the fluid. I've got to be on the fluid to change the color scale of the fluid, which should make sense. Let's take a look at mean velocity, and let me rescale this guy. So again, hitting rescale. Oh, that's a good point. So I chose to output mean velocity at a time step after time step 50, or after the 50th image. And so there's no data here yet. Again, if I go to the very end of the simulation, by that point, and now I hit rescale again, I've started recording mean velocity data. But when I was looking at time step 50, there's no data there. Because when I was setting up this run, I had told the simulation to wait until a certain time step to begin collecting or averaging time data to produce mean velocities and such. And so prior to that time step, although I could open it up, there was nothing there. So now at later time steps, after which I've activated the mean data parameter, it'll start averaging that data and reporting, again, just time averaged values. I can always go back to instantaneous. It's always there. But again, that's a good point. I don't remember when exactly I turned on do mean averaging, but it must have been sometime after 50. Because at 50, if I go back to mean, there's nothing there. And again, we could find this out pretty quickly just through iterating, but I don't want to bore you. So it must have been after 100. Let's see if it was after 200. This is the last time, I promise. Okay, we started sometime between 150 and 200, but you get the point. If there wasn't data there, it's just going to be zeros. So let's go back to the end. Again, there's mean, rescale. I can change the color by going to the heart, the color scale I want. There's anything you can do. Here's blue to yellow. Sure, go nuts. Do what you want to do. So let me go back to the actual velocity, because that's what I'm interested in right now. I can change the transparency of this. Again, there's so much you can do. There's so much you can do with this package. It's pretty easy to use once you find out where the commands are, and that's the point of this tutorial. So either way, I've got now this looking the way I want it to look. Maybe I'll throw the tank back on there. Yeah, I'll put the tank on there. Just maybe we'll say our customer wants it like that. Let me zoom out a bit. I just scrolled my mouse wheel. So now I want to make a movie. So I'm going to go back to the original frame, and I'm going to go up here, File, and I'm going to go to Save Animation. Okay? And I prefer to use the Windows Movie Maker to generate movies. I think it gives me a little more control. So I typically just ignore these settings. I hit Save Animation, and I just go ahead and give this a name. I'll call this Test Velocity. And I'm saving here the JPEG images, right? So I'm going to hit OK, and it's going to march through, and it's going to tell me that the resolution may not have matched what I had given. That's fine. I just click through this. And now it just reset automatically. So now it's actually going through and saving snapshots through time of the flow system. So you can see this is the time evolution of the velocity field in that Y plane due to the motion of the impeller. And it's marching through time here. This tells you how far along it is. And what it's saving are actual JPEG outputs of this image right here. And then I typically like to use a Windows Movie Maker to convert those into a movie. And I'll set up a video on how to do that. But this is just exporting all those snapshots for post-processing within the context of a movie. And again, there are ways to make movies automatically in ParaView. I just find that using Movie Maker is very intuitive. It gives you a lot of flexibility. It's GUI based, which I know lots of people, including me, like. And you know it's going to work in Windows, which is always kind of a concern when you're making movies for PowerPoint and such. But so that's output in a general sense for velocity. I'm going to go ahead and make another video showing how we visualize particles. But if you can do this, you can do half the stuff that you need to do within ParaView, despite the fact there's so much more it can do. In fact, if you go ahead and just open, well, it's generating the movie right now. I'll just stop it. You get the point. So I'm going to go ahead and turn off this movie. If I go to open here, I mean, it just, look at all the files it can open. I mean, it's just insane. There's really not much you can't do. It's a great tool. So, okay, I'll close it there, and that's what you need to know in order to visualize flow field data using ParaView.